everyone. I hope you all are good and you all are practicing questions. Let us for now get at this one. Question ये कह रहा है we have a ball of mass m and that is in equilibrium between a vertical wall and inclined surface. ठीक है? And this inclined surface has negligible mass when it gets compared with the mass of ball. So its mass we can assume to be zero. Inclination angle is given and friction coefficient here is mu. We are asked what will be minimum value of mu for which this equilibrium is possible. So we have to calculate range of mu such that this system, whole system, wedge plus ball will be in equilibrium. So let us talk about writing the free body diagram. This ball, if we write the free body diagram of ball first, this is in contact with two surfaces. So two normal reaction and normal reaction acts perpendicular to the surface. So here perpendicular, if you draw, it will pass through the center because this will be the normal line, right? So this is this one, let's call it N1. And again here it is in contact with the incline. So again normal reaction like this, it will also pass through the center because perpendicular will pass through the center. So this is your N2. Okay, and any other force? No, there is no friction force between incline and the ball surfaces, right? Here on this inclined surface, what will be the forces acting? N2 ka reaction, this incline will feel in this direction. And then this incline is in contact with the bottom surface. Normal reaction on it will be in the upward direction N3. And on this ball also one more force that is mg. Okay, and this incline has no force, I mean no mass, so no gravitational force. And there will be one more force that is friction. So friction on the incline will act in which direction? So incline को आप separately लिख लो. देखो इस पे कौन कौन से forces लग रहे. It is acting N3 in the upward direction, and then this is N2. ठीक है? N2, this N2 will have component. ठीक है? It will have component along horizontal and vertical. Let us break it. So horizontal component will be what and vertical component will be what. So this angle is going to be how much? 45 degree, right? So N2 will have component in this direction equal to N2 by root 2 and in this direction equal to N2 by root 2. ठीक है? So because of this N2 by root 2 acting towards right, this wedge will have tendency to move towards right and then friction will operate. So friction will start acting in this direction. So here on this wedge, friction you will apply in this direction. Okay, so for the equilibrium of this thing, for the equilibrium of wedge, what equations you are going to write? So for vertical equilibrium, सबसे पहले आप क्या लिखोगे? N3 will be equal to N2 by root 2, right? For the vertical equilibrium of wedge, and for horizontal equilibrium, N2 by root 2 will be equal to friction. Now we need to say, we cannot definitely say that this friction acting is the maximum value, right? It may be less than that according to the requirement of this N2 by root 2. Done it? Now what will be the maximum value of this friction? I mean, in this case, we don't even need to write the equation of ball. We will easily get the answer. See here, F को आप क्या लिखोगे? I mean, we need to calculate range of this mu thing, right? So here you just start talking about what can be the range of friction. So friction will be less than equal to mu n. So here friction will be less than equal to mu n value is how much here? N value is N3 between the surfaces of this incline and the bottom surface, right? So that is N3. So this will be mu N3. And here N3 is equal to how much? N2 by root 2. So here friction is less than equal to mu N2 by root 2. कुछ ऐसा, right? So F का value from here, if you write, this is N2 by root 2. Done it? So put this value of F from equation 1 into equation 2. So if you put that value, what you will be getting? N2 by root 2 less than equal to mu N2 by root 2. So this will get cancelled and you are left with 1 is less than equal to mu. So mu is greater than equal to 1. If you are getting mu greater than equal to 1, it means minimum value of mu should be how much? 1 in order for this equilibrium to exist. ठीक है। सो इंक्लाइन प्लेन के लिए हमने चेक कर लिया, वी वर आस्क्ड दिस वैल्यू ओनली, सो वी आर डन विद द आंसर। बट इफ यू वांट टू राइट द इक्विलिब्रियम कंडीशन ऑफ दिस बॉल, यू कैन डू दैट। सो यहाँ से आप देखो, देयर वाज वन mg force acting downward, and here there was one normal reaction like this, and then there was this normal reaction. Done it? There was no other force, right? So this was this. Now you, I mean, just break the forces into horizontal and vertical sense. N1 and mg are already in horizontal and vertical. N2 को आप break कर लो. This angle will be how much? This is angle between horizontal and perpendicular to this incline, 45 degree, right? So N2 will have horizontal component in this direction. How much? N2 cos 45, so N2 by root 2, and vertical, that is N2 by root 2. So if you write the conditions, you will be writing N2 by root 2 is equal to mg, and N2 by root 2 is equal to N1. So these are the two equations you can write for the equilibrium of this ball thing. I hope you have got this question. There was not much to do in here. You just needed to be clear with how to write the equation and what we are asked to calculate. But if you have any doubt, you can always let me know in the comment section. Thank you. Take care of yourself and keep on solving more number of questions.